Okay, remembering that integration is the reverse process of differentiation. So we know that if y equals e to the x, then dy dx is also equal to e to the x. So therefore, if y equals e to the power of x, then dy dx equals e to the x. So therefore, the reverse must also be true, that the integral of e to the x dx will be equal to e to the x plus c. Okay? That's our first rule. So integration of trig functions. Looking at the differentiation, remembering that integration is the reverse process, therefore the integral of e to the x dx is e to the x plus c. Got trig functions on the brain. It's exponential functions. Notice this is just the rule for integrating e to the x, not e to the ax plus b. So we're going to come up with that rule of integrating e to the ax plus b. We're going to do it by investigation, okay? So first one, let's just differentiate e to the 2x plus 1. So that's my example. Here's my solution. So if I've got y equals e to the 2x plus 1, if y equals e to the 2x plus 1, then dy dx equals what? Don't we write it out times the derivative of that, which is 2, which is 2e to the 2x plus 1. Do we get that? So if y equals e to the 2x plus 1, then the derivative is 2e to the 2x plus 1. Now, since integration is the reverse process of differentiation, therefore, I could say, or hence, I could say that the integral of 2e to the 2x plus 1 with respect to x dx equals what? So if you differentiate this, you get that. If you integrate that, you get this. So if you integrate 2e to the 2x plus 1 dx, you'll get e to the 2x plus 1 plus c. We've done this first bit, differentiated, hence find this integral. We've done that. Now find the integral of just e to the 2x plus 1. So if the integral of 2e to the 2x plus 1 is that, well, isn't that the same as saying, to do that, isn't that the same as 2 times this integral? Isn't it the same as that? So integral of 2e to the 2x plus 1 will be the same as the integral of 2e to the 2x plus 1. Yeah? I know that that is equal to this, e to the 2x plus 1 plus c. Okay, so why don't I just divide by 2, and I'll get hence, or therefore, the integral of e to the 2x plus 1 dx is, what would I do with this? 1 over 2. I would get 1 over 2, e to the 2x plus 1 plus c. Please don't worry about the c and say that it's c over 2 or anything like that. Just don't worry about that. Got it? There's the rule. We've just worked out the rule for integrating e to the ax plus b. So girls, if you want to integrate 2e to the 2x plus 1, that is the same as integrating 2 times the integral of e to the 2x plus 1. Because this 2 is just a constant, I can pull it out the front. I know from the line before that that equals this, so I've put this back down there. So if I just want this integral, I divide by 2. Okay? That brings us up to our rule now. Therefore, the integral of e to the ax plus b dx. This is not e to the power of x squared, all right? It's specifically e to the ax plus b, where this is something like 3x plus 5 or negative 2x plus 2 or whatever. That is equal to 1 over a e to the ax plus b plus c. That is the rule for integrating e to the ax plus b. Okay, just some examples similar to question 1. So find the integral of the following, e to the negative 2x. So isn't the rule integral of e to the ax plus b is 1 over a e to the ax plus b? Okay, so what is your a in this case? Negative 2. So it's just 1 over negative 2 e to the negative 2x plus c. It's just negative a half, isn't it? And that's fine. You can put it like that, or you write it as negative a half e to the negative 2x plus c. Same thing. Okay? The next one, that negative 4 is just a constant. So you can pull it out the front, or you can just go negative 4 times. What are you going to get when you integrate e to the 6x? That's e to the ax. There is no plus b. So what do you get? 1 over 6 e to the 6x. Not e, you don't go, plus c. Yep, plus c. So what's negative 4 on 6? Good, negative 2/3 e to the 6x plus c. Here's another one. Integrate the following, e to the power of 5x minus 4 dx. So just do one term at a time. What do you get when you integrate e to the 5x? 1 on 5, e to the 5x. What do you get when you integrate negative 4? Good, plus c, so don't forget that. Here's another one. E to the 2x minus 3 plus 2x dx. Integrating that. What do you get? 1 over 2 e to the 2x minus 3 plus 2x squared on 2, which is x squared, plus c. When you integrate 2x, you get 2x squared on 2, which is x squared. So I get a half e to the 2x minus 3, or I can write it as e to the 2x minus 3 all over 2 plus x squared plus c. Okay? All right, next one. I'm just going to get these ones actually from your book. So evaluate the following in exact form. I'll do question 2D. If you can integrate from 3 to 2, these are exact. I mean, these are, sorry, not exact. They are definite integrals, okay? So let's go. Integrate 3x squared. What do you get? 3x cubed on 3, which is just x cubed. And what do we get here? Minus 1 over 2 e to the 2x. Yes? And you have to substitute 3 and 2. So what have we got? Let's substitute 3. 3 cubed is 27 minus, if x is 3, what's that? E to the power of 6 over 2. Are you okay with that? All of that minus, now if x is 2, we get 8 minus e to the power of, if x is 2, 4 over 2. So we've got, just expanding, 27 minus e to the, actually what I might do is put the whole numbers together. So 27 minus what? 8 minus e to the 6 over 2 plus or minus e to the 4? Plus e to the 4 on 2. Are we okay with that? Instead of writing it all out, I'm just putting the whole numbers together and the e terms together. So 27 minus 8 is 19. Can't you write this as a fraction? I'm going to go plus. Now, to be very careful here, would you like to start your fraction with a negative or a positive term? Yeah, so I'm going to go e to the power of 4 minus e to the power of 6. So e to the power of 4 minus e to the power of 6. Now, look, this could be written as a common denominator in the back as 38 plus e to the 4 minus e to the 6 all over 2. Okay, it could be written with a common denominator. Oh, yes, we could factorise if we want. 19 plus e to the what? 4 bracket 1 minus e squared over 2 if we want. Okay? Okay, question G. Just have a go at that one. Integrate, find that exact integral. Definite integral. Give your answer in exact form. Okay, so what would this be? Integrate e to the 2x. You get 1 over 2 e to the 2x minus, be careful, just write your minus, 1 over what? Negative 1 e to the negative x. Now, before you go substituting, I would be simplifying this. This is e to the 2x over 2. Now what do I do? Plus, that's right, plus e to the negative x. Substituting 3 and 0, what have we got? E to the 6 over 2 plus e to the negative 3 minus what's e to the, I'll just go e to the 0 over 2 plus e to the negative 0 is the same as e to the 0. What does e to the 0 equal? 1. So we've got e to the 6 over 2 plus, instead of writing e to the negative 3, how should I write that? 1 over e cubed minus what? Minus 1. Because it's minus that, please don't put minus. If you want, go minus bracket a half plus 1 with brackets if you're going to mess it up. And then do it on the next row anyway, because we have to collect the like terms anyway. So what's minus, so what is it? Minus what? Minus 3 on 2, that's right. Okay, you can write part of it with a common denominator. I don't know if I'd do it all with a common denominator. You could, I suppose, write it as e to the 6 minus 3 over 2 plus 1 over e cubed, if you want. But that's the exact value.